Okay, we are live. Hello guys, I'm your code specialist Dev Jobalia. Today going to solve the problems related to the some minimum number of platforms required for a railway. So we are going to use Geeks for Kicks. Let's get the key points out of the question and finally or as soon as possible start the implementation work. So we are given arrival time and departure time of all trains that reach at a railway station. Find the minimum number of platforms required for the railway station so that no train is kept waiting. Find the minimum number of platforms required. So we have to find minimum number of platform required. Consider all the trains arrive on the same day and leave on the same day. So arrival time and departure time is for the same day. Arrival and departure time can never be same for a train, but we can have huh? Arrival and departure time can never be the same for a train. Okay. But we can have arrival time of one train equal to different train. So it is never possible that arrival when the train arrives and at the same moment train will departure. It is never possible. And other thing is possible is two trains arrival time is equal. Uh, Drawing part makes the thing slow, but it's quite important. What next? Any given instance of time, same platform cannot be used for both departure of train and arrival of another train. In such case, we need different platform. Okay, so in short, two trains must never come on same platform. So if a train is departing at a time, so at that time another train can't arrive. At any instance of time cannot be used for both arrival and departure. So same time can't be used. So what points can we get are find minimum number of platform such that consider all train arriving today are given, arriving and departing, such that arrival and departure of train don't collide with other. Two trains can have same arrival time. One train can never have same arrival and departure time. So quite simple. Let's dive into the example. What example have they taken? Mm, so this is the arrival time and this is it. So at the departure time of 9:10, after which we can take this train, which will this both will be attended in one platform. Now since the second is at 1200, or no, yes 1200, and this will need to be taken into consideration for second platform. After that, again another platform will require for 1100 because there are no trains getting emptied at this time. Now what happens is This is 1500. We can place it in the platform 1 because by 1200 this is empty. Now next we can place this one in either 2 or 3 because in the first platform there is 1500 train which will depart at 1900, so we can't place it there. So the logic might quite be simple. So how we will begin is, let me show you the implementation in the diagram itself. So let's move on to the diagram in pen and paper. Let's take some difficult example. What the example could be? 19. This is quite simple. Okay, keep the example the same. 900, 940, 950, 1100, 1150, 11, 1500, 1800. This is the arrival times: 910, 1200, 1120, 1130, 1100, 1900, 2000. So this is arrival, departure. Are you guys able to see the whole page? Yes, now you can. So I was repeating this stuff because I was writing it. So you can go back it and listen to it what I have written over here. Uh, so our thought process. I'm directly jumping into the greedy solution. And what is the thought process is, sort both the arrays. So what will happen is there can be a mismatch since uh, the pre the above array is sorted. We will not do it 910, then 1120, 1130, 1200, 2000. So we sorted it. So the same trains are not aligned, but it is not a big of a concern. Why? Because we are just uh, considering what we are just doing. We are just considering uh, we don't care which train is going to come or not. We are just considering if the arrival time collides or not. So what we see is at the earliest, since it is greedy, we will see at the earliest which we can allocate fastest and go ahead. So at the first, we can allocate 900 train and which will be occupied till 910. After which we will see 940 is the train, but the departure time is greater than 940. So we will have to take another, sorry, the previous departure time is less than the current arrival time. So we can place the same train out there. Uh, can guys give me 1 second? So what's the thought process is this train, first train is arriving at 900, it will occupy some space. And at the earliest, one train will depart at 9:10. So since at the earliest the train will get departed, we can use the second train for in within the same platform. Arrival time, because the arrival time is greater. So after placing the same train out here, now we will see uh, what's the next arrival time, 9:50. But the late the latest arrival time depart time is 11:20. So what's happening is the departure time is greater. So we have to use another platform for the 9:50 train. So currently we are taking two platforms. So how we will move ahead is the next train is taking 1100 time, which is again less than the last departure time, which is 11:20. So we will take another platform. So now currently we are holding three platforms. Which what will happen next is after which we will move on, which is 1500. So we will check what's the latest departure time we have encountered, which is 1120. So since 1500 is greater than 1120, we will place that train on the departed train of 11:20. So we will not require any extra trains, array we say platform. But now what happens is we will move on ahead. So another train which was departing at 11:30, and now new train is arriving at 1800. So we can place it over here. So we will not require another platform for that. So that was the thought process. In simple terms, if I had to revise it again, we are just interested if the arrival time doesn't collide with the previous departure time. If it does, we have to take another platform. It's as simple as if there is currently a machine being used, we can't use it until the departure has been confirmed, and the earliest departure is given in the second array. So since the earliest departure is greater than our arrival, we will by default have to move on to the next machine. So if it's quite clear, let's do a dry run. Mm, how we will start is we will require I and J platforms, and uh, platform needed a counter. So I is equals to 0, I starts from 1, J equals to 0. Platform needed by default, platform needed equals to 1 by default. So this was the initial, after which we will check if arrival time of 1, which is I, is less than departure time of J. So what we will do, arrival of I is less than departure time of J. So in the question that was we can one train arrival and departure time cannot collide with so we cannot have the same arrival and departure of two trains. Is that the case? Let us read the question again. Arrival and departure time can never be same for train, but we can have arrival. Okay, for the same train. So we can do less than or equal. If arrival of I, which is the second train, is less than departure of first train. So arrival of 1 is 9:40, which is not less than departure of J. So we will not require extra platform and we can increment J pointer. It is false. Uh, so we will not require an extra platform. So we are incrementing J. But platform needed. We will keep it as we will decrement platform needed also. We will make it 0. So this was one second case. Now J has been incremented. Arrival time is again arrival time is 1. Arrival of 1 is less than equal to departure of 2. Departure of 1 because J was 0. So is arrival of 1 less than equal to departure arrival of 1, which is I, is less than equal to departure of 1? Yes, it is true. So what does this mean is now what is happening? I have a doubt out here. Platform needed. We have placed this. We have incremented I. So we have placed 940 train. Na? So J plus plus has happened. Hmm, what is the problem then? Departure of 1200. So now the next train will depart at 1200. And what's the pain? I is equals to 1, J equals to 0. Arrival of 1 is less than or equal to departure of 0. Arrival of 1 is false. It is greater. So platform meter is minus J plus. Arrival of I, which is 1, is less than or equal to departure of 1. So it is true, which means we will require another platform and increment our I, which will become It was 1. It will become 2. So arrival of 2 is less than equals to departure of 1. Yes, it is true. So what was happening? Why I was confused is since we have taken into 940 consideration, why we are doing this case again? It is so to again retain our platform needed thing because it was 0, but we needed that one platform. So now we will check the second part. So now arrival of 2 is less than departure of 1. So what is happening is this train is arriving earlier than the train which is going to depart from platform 1. So we will require another platform, so it will become 2. I will again become plus plus which will result in 3. So now it's going to be fast because I was also into a doubt. So arrival of 3, is it less than departure of 1? It is not. So we will again, acha, it is, yes it is. Arrival of 3, 0, 1, 2, 3, 4, 5. Arrival of 3 is still less than. So platform needed will again be incremented by 3. So as we increment platform needed, we will keep on saving the highest value. So till now the highest value is 3. So what will happen is now we move ahead. Now we are in need of 5 platform. Now for array of 4 less than equal to departure of 1. Now array is 4. Now it's a false case. Now since 1500 is greater than the departure time of platform 1, we can keep or reduce. Why we are reducing you will understand later on. Reduce it and increment j. J will become 0, 1, and now it's 2. So for the sixth case, what's happening? ARR of 4, is it less than equal to departure of 2? 4 and departure of 2, it is not. So false. Platform needed equals to 1. J plus plus, it will become 3. So this train has departed from the platform. So now only one platform is occupied. This is the, what does this mean is platform occupied till current timestamp. So till 1500 or less than that, or and greater than 2 1120, there is still a need of one platform. So now let's move on. 7 ARR of J 4, it is departure time of 3. Still it is less. Uh, so still it is greater. Arrival time is greater. So again false. Platform needed equals to 0. J plus plus. It will become 4. Now where are we? 1900. So now all the trains have departed and we don't need any platforms. So ARR of 4 less than equal to departure of 4. Yes, it is less because 1900 is greater. Departure time is greater now. So platform will be needed. One platform will be needed. So now we can move on. Where was the last time? Now we can move on to 5. Why we will move on? because one train has arrived at the one needed platform. Now we will cater to the next train, which is ARR of 5, arrival of 5, departure of 4. Since departure time is again greater, arrival of this is less than departure. We will again need another platform. Okay, let me think. Arrival of this is less than. Again, yes, we will again need it. We were on right track. Yes, I plus plus. But now I has been equal to the length. So this was a loop. Whole thing was in a loop. We will get out. Mm, so that was the case. I mean, I should have done an example dry run also. Let's do that now. So for the first case, are you able to see? Let me check on OBS. For the first case, this you aren't able to see. Let me take the screenshot and show you all. Windows Shift S. It will take some time because I will have to open the file explorer, move it on the right, go to pictures, then screenshot, then where is the image? We have to search it, then upload it on OBS, then increment the size. It's a hassle, man. You have to understand and appreciate it. Similarly, DSA is also hassle. If I do this, okay. So the for the first iteration, which was, let me take the array out over here. 9, 10, 20, 1200. Acha, the sorted part should come out here. 1200, 2000. So I is out over. We will require I at arrival time. It's out over here, and J is out over here. So since arrival time is greater, we were initially occupying one platform, and for the arrival of J array 940, we will keep the same platform because departure time is less than it. For the second thing, now we have placed two platforms or two trains on one platform. We will move ahead. Let me just copy the array. This is 2000. So now we are at, so these both are placed na. So now we will come over here and J is out here. So one platform is still being occupied till 1200, but now it's 950. So now we will take 950 train over here. So after placing this, we will move ahead. Since the train out here will take by default 11:30, so At the minimum, it will take 11:20. But the new train is also less than the departure time, so we will need another platform. So that is the case we are solving out here. Now it's 1500, so I is coming out over here. It's 1500 and this train will depart. So now we will place the 1500 train out over here, which will now depart at, this is 1500 train. So this is occupied till 1500 at the least. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. I've missed one. 1100, 30, 12, 2000. 1, 2, 3, 4, 5, 6. 1, 2, 3, 9, 10, 12, 1100. So I have missed 1900 value. 1900 is out over here. So approximately it is going to stay till 1100. So, so now the second train of 1800, this will take around, this cannot be occupied. Why? Let's think. For this train 950, we move on. So J incremented. So J is, so this is till 1900, means at the worst case 1900 is out here. So we can't place 1800 over here. So we will do 1800 on the next platform. So if you are able to understand, well and good. Otherwise, while implementing and you doing dry run on your own, you will get it better. Let's get this out. Mm, Now let's go into implementation. Hmm. Now, how the thing begins is arrays dot sort arrival time arrays dot sort departure time. What we are taking into consideration is answer platform. We are keeping at the least one will be needed. Uh, Occupied, currently occupied equals to 1, keeping it as default. What else we need? I and j, int I equals to 1, int j equals to 0. J is for maintaining the, what we say, departure time, and I is for arrival time. I is less than n and j is less than n. If arrival of I is less than or equal to departure of j, this means we will require another occupied equals plus plus. We will require another platform. The next thing we will do is increment. So This is occupied. So now we will increment I. Else case is, what is else case? Let me write for you all. Array of I is greater than departure time of J. Occupied, occupied minus minus J plus plus. If answer less than occupied, answer do math dot max answer or occupied. This is done. We will return answer. That was it. Let's go. So I was not showing you all the time complexity. I will do it currently after submitting this question. What cannot find symbol? Okay, it's not departure. D control H DEP replace all. What's the problem? Occupier minus minus plus plus is all correct. Let me ask ChatGPT. Session expired. Hmm. Login. Let me think. We are not assigning answer. Okay, so this is done. Let's submit it. And for time complexity, mm, it is O of n log n and space complexity of 1. Why O of n log n? Because as we can see in our implementation, we are log sorting this both array which is taking n log n and iterating the thing for n. So O of n log n plus n log n plus O of n time complexity, which can rounded off to O of n log n. Space complexity is 1 because of no need of auxiliary variables and all. So that was it. I just added this point. So off and login it is. So thank you guys for being with me. Till then, bye bye.